Hey Tenfold, my name is Simone. I'm from the East End. Please help me with this question.
Yes, so Simone, the question that you sent us, it's more or less similar to the first question that we did. It is about similarity and it is about proving a tangent. So let's have a look at what the question is saying. It says, in the figure, triangle ABC is inscribed in the circle M. So ABC is inscribed, as you can see it. It means the three vertices of that lie on the circumference of the circle. Then the other statement says D is a point on BC such that, so this is important, AC squared is equal to BC multiplied by CD. Remember I said if there's a squared, it means there's two triangles that are sharing one common side that are similar to each other. And then also I have AC. I have AC there. Sorry, let me just use different colors so you guys can see what the things are all about. AC multiplied by AB is equal to BC multiplied by AD. Then EC is a line segment such that CE is parallel to AD. That's very important, by the way. Now, quickly, one thing that I want you guys to please do under Euclidean geometry is that whenever you're solving Euclidean geometry problems, try and transfer what the statement is saying to the diagram that you have at hand so that your life can be a bit easier. You'll see after doing that, you would have answered 2 or 3 questions under it. Now here we are told that this line and that line are parallel. So it means that this angle here will be equal to that angle there. And the reason for that, it will be alternating angles or alternate angles. So that's what I have so far. Then from there, I can just pause there because I can't really talk about co-interior angles. It really serves no purpose in this particular question. Then let's look at the first proof that they want us to do. They want us to prove AB times CD is equal to AC times AD. So it's also similarity there, right? So proving similarity, it means from the statement there, I have AC divided by BC, which is equals to CD divided by AC. So it's two triangles that are sharing one side, which is AC here. So it means it's triangle ABC, which shares a side with a triangle DAC. So that's what I have at the moment. So it means here I have triangle ABC, which is similar to triangle DAC. And then remember my reason for this will be sides in proportion, which is what we have up there. Therefore, if I want the ratios, or rather thus, if I want the ratio that they want me to get, remember they want me to have AB and AC. So I have AB there, which will go with DA, and then I will also have AC there, which will also go with DC or CD rather. And therefore the ratio will then be AB divided by AC is equal to DA divided by CD. So I'll write that as AD, it doesn't really matter. And then AB, remember you cross multiply from here, AB multiplied by CD will then be equal to AC multiplied by AD. So we just need to try and check whether that's what they wanted. Yes. So you see they have AB multiplied by CD is equals to AC multiplied by AD. Remember guys, maths is food for the soul. If you do it well, it will nourish every fiber in you. EC is a tangent to the circle M at C. So I want you to prove that this line is a tangent. Let's just transfer what we had from that side. Remember we spoke about this angle being equal to that angle, and we said the reason for that will be alternate angles. Now, what they want me to do is to try and prove that this line here, this line is a tangent to this circle. So what did I say to you? I said there's two things. There's a conclusion that you need to make, one. Number two, there's something that you are required to prove. The required to prove in this instance will be the fact that 10 chord theorem exists. The second thing, which is the conclusion, then if it does exist, then then the line is a tangent. Your reason will be converse of, because converse means you've proven it that it exists. So you went behind. You didn't go straight. It's like when you do the things that need to be done. That's what you're trying to do here. So that's what I mean. Now, going back to the question, I said to you, triangle ABC is similar to triangle DAC. Remember what I also said last time. I said when I have A here, it means A will be equal to D there, because that's proportionality. And also I will have my B being equal to A there. And then lastly, I will have my C being equals to C there. So what I want here is, I will firstly write up here my required to prove, or rather let me write up there, because so we can see what exactly the order of the proving is. Required to prove is that C1 is equals to B. That's what they want you to prove. If this is true, it means 10 chord theorem exists, because this is a chord. This is a chord that is a tangent. Therefore, the angle between the is equal. No, I'm lying. Sorry, guys. Remember, in maths, we are not wrong. No, we are just liars. So, though we quickly see our lies. It means A1 plus A2. So, the whole of A. So, sorry. It's the tangent, which is this. It's the chord, which is this. I'll just do this. And the tangent, which is that. The angle between there is equal to the angle in the alternate segment, which is this angle here. So I'm trying to prove that C1 is equal to A1 plus A2. Therefore, I will then say from this, A, which is A1 plus A2, is equal to, because it is in the big triangle ABC, it is equal to angle D1. Right? If it is equal to D1, this is because we're talking about equiangular. Guys, remember, the day I go to England, I will come back knowing English like nobody's business. Equiangular. Oh, yes. So this is equiangular. Therefore, what I want to try and do then is to try and link the D1 to C1, because that's what I want to do. I want to conclude that A1 plus A2 is equals to C1. Therefore, I will say, but D1 is equal to C1. Remember what the reason was for this? It's the yellow part. It's the alternating angles, which were given in the statement, so you don't really need to mention them. Therefore, C1 will then be equal to A1 plus A2. Your reason can just be they are both equal to D1. Right? They are both equal to D1. Then EC is a tangent. My reason for that will be converse 10 chord. Right, guys, remember, you don't write statements in full. When you write your reasons, you just write abbreviations of these things. Now, what we've looked at right now, guys, was we tried to look at proportionality. Proportionality given as a ratio to us and a product of certain sides that are in proportion to each other. From there, you then conclude that the two triangles are similar to each other. If they are similar, it means there's equiangularity that exists. See that? Did you see what I just did? Yes. So there's equiangularity that exists in there. So I'm playing with these words, guys. I'm closer to going to learn that. So after talking about that, then we try to prove 10 chord theorem. So we try to prove that 10 chord exists. Not the actual theorem, that it exists in this instance. If it does, then a line is a tangent. Therefore, that's what we try to do.